Hi everyone, welcome to one more classes on econometrics. In your syllabus, after the estimation part, there is a topic called normality of distribution and how to test the normality using descriptive statistics. Okay, so in this video we will discuss what is this normality is and why we are assuming the normality and how to test this normality. Okay, so uh, so far in the couple of previous classes we have discussed the how to find out the value for beta cap 0 and beta cap 1. Okay, so this part is known as the estimation part. Okay, but the classical statistical inference consists of both estimation as well as hypothesis testing. Okay, so we have covered the estimation part already, and we have already seen that under the assumptions of classical regression model, okay, the parameters or the estimators beta cap 0 and beta cap 1 possess certain desirable properties, and these properties are contained in the well-known Gauss-Markov theorem or blue properties or blue theorems. Okay, and you have to understand one thing: this beta cap 0 and beta cap 1 are random variable, because whenever you change the sample, your beta cap 0 and beta cap 1 will also changes. For example, in our previous example, we have the population was 60 families. Okay, so we have selected 10 families and we have got one value for this beta cap 0 and one value for beta cap 1. If we change the samples, if you increase the sample or if you remove some number from this and if you add a new numbers, you will get a new beta cap 0 and new beta cap 1. It means that whenever you change the sample, your beta cap 0 and your beta cap 1 or your estimators will also changes, and because of this thing we call the estimators are the random variable. Okay, and in regression analysis our aim was not only to estimate the SRF but also to infer about the PRF. There are two steps. First you find out the SRF, then you assign this SRF value to PRF. Okay, so the most important step is to infer about the PRF from SRF. Okay, so in order to infer about PRF, or in order to find out, in order to do certain hypothesis testing about PRF, we need to find out the probability distribution of estimators beta cap 0 and beta cap 1. Okay, yes, then the probability distribution of these estimators will be depends on the assumption about the population, the probability distribution of UI. And knowing the distribution of UI is very important. Okay, so what I'm saying that the probability distribution of beta cap 1 and beta cap 0 is depends on the probability distribution of U. Okay, and the OLS does not make any assumptions about the probabilistic distribution of UI. So we have seen many assumptions. In that assumption we didn't see an assumption regarding the normality or assumption regarding the distribution of UI. Okay, but in regression context it is usually assumed that UI follows, that error term follows a normal distribution because of two important reasons. Okay, the first reason is that UI is mainly a variable that influence, or is a variable that included the effect of omitted or neglected variable. UI means all the variable that we have neglected from the model, or that we have removed from the model. Okay, and we assume that the neglected variable's impact on the dependent variable is very small. Okay, because we assume that sigma u cap square is minimum. Okay, so using the celebrated central limit theorem in statistics, we can show that if there are large number of independent and identically distributed random variables, the distribution of their sums or totals tend to be also normally distributed. Okay, so assume that in our consumption example, consumption depends on income. There are some other factors like wealth, number of family members, living area of the family, okay, number of earning members. So we are removing all these variable, and instead of this variable we are just putting a u. Okay, so this u contains a lots of independent variables. Okay, so in total the effects of all these the sum of these all independent variables will be normally distributed as per the theoretical founding of, or theoretical what we call suggestion by the central limit theorem. Or as per central limit theorem, if there are large number of independent variables, then their sums will be normally distributed. Okay, so CLT or central limit theorem provides a theoretical justification for the assumptions of normality. That's the first thing. And second thing is, when we take the normal distribution, there is a property. The property is that any linear function of a normally distributed variable is itself normally distributed. Any normally distributed variables is itself, any linear function of a normal distributed variable is itself normally distributed. Okay, and you know that OLS estimators beta cap 0 and beta cap 1 are linear function of UI. Therefore, if UI are normally distributed, then beta cap 0 and beta cap 1 is also normally distributed. Okay, so because of these two important theoretical justifications, what we are assuming that UI is normally distributed, and because of the UI is normally distributed, beta cap 0 and beta cap 1 is also normally distributed. Okay, so apart from this, there are a lots of theoretical justification for the adoption of the normal distribution, or for the assumption of this normality. Okay, I am not going for that because these are the two important things. Now, with this normality assumption of beta cap 0, normality assumption, the classical regression model turned to as a rename as a classical normal linear regression model. Okay, so without this normality assumption, we usually say that it is the regression model is classical linear regression model. Okay, but when we include the normality assumption, then our regression will be renamed as classical normal linear regression model, CLNRM. Okay, which assume that UI is distributed normally and independently with average value of UI is equal to 0, variance of UI is equal to constant number, and covariance of UI and Uj is equal to 0. That means, as you know that if there is a distribution, then it will be distributed independently and identically with its mean and variance. Okay, but here the mean is equal to is 0 and the variance is equal to small sigma square. Okay, so we can say that the U term, the error term is normally and independently distributed, NID, it is usually called NID, with with a mean 0 and a variance small sigma square. Okay, so this is about the normality of here. So what we are doing is that we have to find out, in order to do certain hypothesis testing about beta cap 0 and beta cap 1, we need to find out the probable distribution. Okay, so we cannot derive a probable distribution from this for this beta cap 0 and beta cap 1. Its distribution is derived from the distribution of ui, and distribution of ui is normally distributed, so the distribution of beta cap 0 and beta cap 1 is also normally distributed. And how we can test it? In your syllabus, it says that, or the syllabus, the topic is how to test the normality using descriptive statistics. Okay, but in econometrics we usually do not test this normality using the ordinary descriptive statistics. We usually refer for certain advanced method. Okay, but in your syllabus it asks that how to test this normality using descriptive statistics. So let me tell you that. Okay, so a normality test is basically used to determine whether the sample that we have derived from a population is normally distributed, or the sample that we have taken from a population, that population is a normally distributed population or not. Okay, so it can be tested using different ways. Using graph we can test. How we can test using graph? You can just plot this data in a xy plane or in a histogram and look at this, how the histograms look like. Okay, so in the case of the first graph, you can see that it is normal distributed, because in this distribution mean, median and mode will be equals. Okay, whereas if mean, median and mode are unequal, then we will have a unequal distribution or a symmetric distributions. Okay, yes, that's the way we can find out the normality using graph, symbol graph. Okay, then if you go to advanced graph, then you can see that there is a one more test called QQ plot, or quantile in quantile plot. Okay, so I'm not going for that details. Okay, you can just simply write this if the question is asked. Then there are certain tests which is based on certain descriptive statistics. Okay, the first one is back of the envelope test. Okay, so using this test, how this test is working, it takes the maximum and minimum values and compute their z-score or t-statistics. Okay, number of sample standard deviation that a sample is above or below the sample mean. We take the sample mean and we'll compare how many samples are, or how many sample standard deviation are below and above the sample mean. Okay, and it compare into the with the 68, 95 and 99.7 empirical rule. You might have learned there is an empirical rule in normal distribution. Okay, then that means mean plus 1 standard deviation will cover 68% of the total area. Mean plus 2 standard deviation will cover 95% of the total area under the normal curve, and mean plus or minus this 3 standard deviation will cover almost 99.7% of the total area. Okay, so using this criteria, you can compare this with your z-scores and you can arrive at a decisions. Okay, or most importantly, a most popular thing is that we can get the information about the normality using third and fourth standardized moment test, or this is known as Pearson gamma coefficients. Okay, so it is nothing but we are comparing, or we are finding out the skewness and kurtosis based on third and fourth standardized moment. How we can do that? Okay, I hope that you know how to find out the moment. Okay, then with that knowledge I am keeping that in mind, then gamma 1 is equal to root beta 1, where beta 1 is equal to third moment square divided by second moment square. Okay, then gamma 2 is basically the kurtosis. It is equal to beta 2 minus 3, then beta 2 is equal to fourth moment divided by second moment square. Okay, then if the coefficient of this gamma 1 is equal to 0, then and the gamma 2 coefficient is plus 3, then you will have a mesocortic curve or exactly normal curve. Okay, and if your gamma 1 is equal to 0 and your gamma 2 is there are some other other values other than 3, plus 3, above this 3 and below this 3, okay, then still you have the normal distribution curve, but the shape of the normal distribution curve will not be exact normal, or it will be certain time it will be leptokurtic, or it will be a platykurtic curve. Okay, so this way we can use the descriptive statistics to find out the normality test or normality. And apart from these, there are certain tests based on frequentist statistics like Jacob-Barrett test, Shapiro-Wilk test, and Pearson chi-square test. Okay, and if you are very familiar, if you are doing any research and all, then you will be knowing these tests. Okay, so in econometrics, we usually test the normality using Jacob-Barrett test. Okay, so we will assume certain thing about normality, and on the basis of certain statistics we test it. Okay, then the advanced Bayesian statistics methods are there, like Kullback and Libler divergence method. Okay, so these are all certain methods to find out whether the underlying population from which the sample is drawn is normally distributed or not. Okay, yes, so that's all about, yes, so that's all about the normality test. Okay, so I hope you understood what is normality. Here in regression, we are, normality means what? Normality of the estimator beta cap 0 and beta cap 1. Okay, it is normally distributed because UI is normal distributed. How UI is normal distributed? On the basis of central limit theorem. Okay, and since central limit theorem is assumed that large independent variable and their sum will be always normal distributed. Okay, then from the property of the normal distribution itself, we can say that beta cap 0 and beta cap 1 will also normally distributed. Okay, and we can test it using graphical method, or simple descriptive statistics, or frequentist method, or Bayesian method. Okay, so I hope that you understood what is normality and how to test it. Okay, okay, thank you.